Hello, Pre-Calc Honor students. Mrs. Myers here. We are on our second day of Section 5. So just a quick little reminder here. These are the notes that that you went through and took from the first video on Section 5, and now we are going to continue. So we are on Roman numeral 4, okay, and we are doing multiplication of matrices now. So not scalar multiplication, but actual multiplication of matrices. Now, a little bit different here with this, okay, a little bit lengthier, which is why I'm just making this a separate day. As per the matrices themselves, you have to have, okay, in order to do matrix multiplication, you must have, okay, the same number of columns in the first matrix as the number of rows in the second matrix. And then the product matrix matrix's size will be the number of rows in the first matrix and the number of columns in the second matrix. Okay, so here is an example for you, okay? So if I give you matrix A, and I tell you it's a 3 by 2 matrix, all right, so let's say we have -1, 3, 4, -2, 5, 0, okay? That we have matrix B, which is, let's say, 2 by 4 matrix. And that would be -3, 2, 7, 8, and then -4, 1, -6, -5. Then the product matrix, okay, from these two will be able to be done, okay, because look, you've got the number of columns from the first matrix being the same as the number of rows from the second matrix. So the product matrix AB will therefore be a 3 by 4 matrix. Okay, so this is going to be a 3 by 4 matrix. Again, your product matrix is always the number of rows from the first matrix and then the number of columns from the second matrix. Now, how you get each of these cells, okay, a little bit lengthier of a process here. It's not hard at all, okay, but a little bit lengthier of a process. So remember how we always name the size of the matrix by rows and columns? Well, you always name each cell as rows and columns. So this is row 1, column 1. This is row 1, column 2, row 1, column 3, and I did not give myself enough room, so let me fix this. Okay, and then row 1, column 4. Okay, and then to keep go, this is row 2, column 1, row 2, column 2, row 2, column 3, row 2, column 4, and then this is row 3, column 1, row 3, column 2, row 3, column 3, and then row 3, column 4. Okay, so how are we going to get each of these values? Let me just redraw this again here. Whoops. Okay, and I don't really know how you want to necessarily write this up. It's kind of hard to write it up in directions. Okay, but what you do is you take the entries of the row and the entries of the column that names the cell, and you add together the products of each of the corresponding entries. So what I mean by that, so right here, row 1, column 1. Okay, so here's row 1 values. Okay, see these two row 1 values? Here's of the first matrix, and then column 1 of the second matrix. So here, see it's column 1. Okay, so off to the side here, I'm just going to write to get row 1, column 1. Okay, what we do is we take the first entry of row 1 from matrix A. We take the first entry of column 1 from matrix B, and we multiply them together. So -1 times -3. Now I add to that the next entry from row 1 from matrix A, and then the next entry from column 1 of matrix B. So that'd be 3 and -4, and I multiply those together as well. So this is 3, this is negative 12, and that adds together to be negative 9. So this first entry is negative 9. All right, but what about the next one? Okay, so if I want to do row 1, column 2, so I do row 1 from matrix A, but then I do column 2 from matrix B, okay? And then I take negative 1 times 2, okay? So I multiply the first entry together of the row and the column, and then I add it to 3 times 1, right? Because that is your product of your second entry from the row and from the column. So this is negative 2 and 3, and then that gives you a 1, okay? So let's do that again for row 1, column 3. Okay, so I have row 1 of the first matrix, column 3 of the second matrix, and I go negative 1 times 7, and I add to it 3 times negative 6, and then that gives me negative 7 and negative 18, so there is negative 25. All right, so let's just finish up this row. So row 1, column 4, so I have negative 1 times the 8, and I add to that 3 times the negative 5. So that is negative 8 and negative 15. So that gives me negative 23. Okay, so that's the end of row 1. Now I want to just do a couple of other random ones. So why don't we do right here? Okay, so row 2. So let's just put all the entries first of all. So row 2, column 1. Okay, then it would be row 2, column 2, row 2, column 3, row 2, column 4. Okay, and then we would eventually have row 3, column 1, row 3, column 2, row 3, column 3, and let's just squeeze it over here, row 3, column 4. Okay, so you can go ahead and finish all that up if you'd like, but anyway, what if we have right here, so row 2, column 3. Okay, let's just get this entry right there. So row 2, so that's here, the 4 and the negative 2, okay, and then column 3, that's this column right here, okay, so we'd have 4 times the 7, and we would add to that negative 2 times the negative 6. So this is 28, this is 12, so then that sum would be 40, and that's what's right there. Okay, so why don't we do this entry right here? Why don't we do row 3, column 1? Okay, so row 3, okay, there's row 3, column 1, right, there's column 1, so we would have 5 times the negative 3, and added with 0 times the negative 4. So there's your negative 15 plus 0. So of course that is just negative 15, and there you go. All right, so doesn't seem so bad, right? Seems a little, long and lengthy, but really not too bad. Anyways, what if I asked you to do matrix B times A, right? In the previous lesson, we talked about the commutative property for matrix operations such as like addition and subtraction. So what do you think about for multiplication? Okay, could we turn this around? We know obviously that when we do negative 3 times negative 1, it's the same thing as negative 1 times negative 3, right? We know that that answer is 3, and that multiplication is commutative, but is matrix multiplication commutative? So anyway, matrix B is a 2 by 4 matrix, okay? And I want to multiply that by matrix A, which is a 3 by 2 matrix. So anyway, can this be done? Okay, could I reverse it and can it be done? Well, look, do these inner dimensions match? Is the number of columns from the first matrix the same as the number of rows from the second matrix? And that is not the same, okay? Not the same. So then what that means is that this has no solution. You cannot do that, okay? So recall that, pretty much for the most part, matrix multiplication, okay, is not commutative. You cannot switch that around. You might be able to come up with some instances where it would work, but just because sometimes it can work doesn't mean that it always works. If you can find one instance where it doesn't work, then basically it negates the whole process and you simply say that it cannot be done. All right, so anyway, so you've got some problems with matrix multiplication tonight for homework, and I hope they go well. Be well. Bye.